Okay, so today we are going to continue our unit on decimal computation, and we are going to start division today. We're going to start by dividing a decimal number by a whole number. This still goes along with our Common Core State Standard 5 NBT 7, which is to add, subtract, multiply, and divide decimals to the hundredths. When we start division, we're going to start by reviewing the parts of a division problem and how they look. Division is unique in the fact that it can be represented three different ways. The first way is the one that you're most familiar with, probably, and that is as a long division problem. In this case, we have our dividend, which is the amount that is being divided up. It would be your whole amount, is underneath the long division symbol. The divisor, which is the number you're dividing by, is on the outside, and then your quotient or your answer is the number on top. The second most common way that you'll come across division this year is written using this symbol, which you're all familiar with. You've seen before. It's the division symbol. But when it's written this way, your dividend is the first number, your divisor is the second number. Okay, which is different than the way the long division works. Most mistakes when a student has a problem written this way and they go to do long division is they don't have the numbers written in the right spot. Okay, and division is not commutative, so you can't reverse the numbers and end up with the same answer. Okay? And the third way, the least common way, at least at this level, of seeing division problems is where it almost looks like a fraction. And we'll discuss the relationship between fractions and division when we get to our fractions unit. But if you do see something that looks like a fraction, know that the dividend is the number on the top, or your numerator if you're thinking about it like a fraction. The divisor is the number on the bottom, and again your answer is a quotient. Okay? So when we start to do a few examples, what we're going to start off with is a problem that is pretty easy. When we are dividing a decimal number by a whole number, the division process is identical. The only difference is what to do with the decimal and how far to take it. Okay? So when we have our decimal point here, in our number 48 and 33/100ths, it's going to go straight up into our quotient. We want to make sure we bring it straight up and that we line up our numbers carefully. Because now that we have a decimal in our answer, the position of those numbers in the quotient is going to be extremely important, because if your decimal's in the wrong spot, it's a different number, and that would result in an incorrect answer. So let's say that in this problem, the situation that would match this problem, let's say you have $48.33 and you want to divide that up equally among three people. Okay, so we brought our decimal point straight up into the problem, and now we just start our long division process. Does 3 fit into 4? Yes, it will. How many times without going over? Once. So again, I make sure that I write that 1 on top of the 4. 1 times 3 is 3. When I subtract, I get 1. I check, is the number I get when I subtract less than my divisor? It is. So I'm okay to bring down my next number, in this case an 8. And the process starts over. How many times will 3 go into 18? Without going over, 3 goes into 18 6 times. So I make sure I put that 6 above this 8 in my quotient. 6 times 3 is 18, so when I subtract I get 0. Again, less than 3, the number I'm dividing by, so I'm okay to bring down my next number. And again, I start over. How many times will 3 go into 3? That's going to be a 1. 1 times 3 is 3, so when I get to subtract, but I still have another number to bring down, so I have to keep going. 3 goes into 3 again once. This time I end it with 0. I have no more numbers to bring down, so my answer is so my problem is finished. My answer would be 16 and 11 hundredths, or to go back to my situation, it would be each person would receive $16.11. So again, you see that the division process is identical. The only thing we need to make sure we do is bring our decimal point straight up and make sure that we are very careful about our lining up of the numbers in our quotient. So another example, and I'm going to use an example written this way. Let's say that I have the number 12 and 4/10, and I want to divide that by 8. Okay? So the first thing I'm going to need to do is to rewrite that problem as long division. Remember, the divisor is the second number. That's going to be on the outside. The dividend is the first number, so that's on the inside. Now I'm going to have my process start off just the same way it did before. I bring my decimal point straight up. And now I more or less ignore that it's there, and I just divide like I normally do. Does 8 go into 1? No, it doesn't. So then I put the first two digits together. Does 8 go into 12? Yes, it does. How many times without going over? Goes in once. That 1 has to go above the 2 because I'm going into 12 and not just 1. Excuse me. 1 times 8 is 8. When I subtract, I get 4. Is 4 less than the 8 I'm dividing by? Yes, it is. So I'm okay to bring down my number. So now I have the number 44. Does 8 go into 44? Well, yes, it does. 8 goes into 44 5 times without going over. The 5 goes above the 4. 5 times 8 is 40. And when I subtract, I get 4. Is 4 less than the number I'm dividing by? Yes, it is. So I know I'm on the right track, but I have a little problem here. I don't have any more numbers to bring down, but I don't have a 0. Now, in whole numbers, this wasn't really a big deal. We would just say I would have a remainder of 4. Now that we're moving into decimals, we really can't have remainders anymore. It doesn't fit with our decimal answer. It just wouldn't look right to say I'd have 1 and 5/10 with a remainder of 4. Well, that doesn't make a whole lot of sense. So what we do in this type of a problem is we're going to annex a 0 on the end of the dividend. Adding a 0 at the end of a decimal number does not change its value. What it does allow us to do, though, is bring that another 0 down and change that into a 40. Now I can say, oh, well, 8 does go into 40 5 times. 5 times 8 is 40. When I subtract, I get 0. Have a 0 here. No more numbers to bring down. So I'm finally finished with this problem. My answer would be 1 and 55 hundredths. So here again, 12 and 4/10 divided by 8 is going to be 1 and 55 hundredths. Okay? So sometimes you're going to have to annex a 0 so that you do not have any more remainders. Okay. Let's take a look at the third type of problem that I want to show you. And this one can be probably the most difficult for students to really understand. Let's say that I have the problem 3 divided by 5. At first glance, you're looking at this and saying, I set it up wrong. You can't have the bigger number on the outside. That's what the teachers have always told us in long division, that the bigger number always has to go on the inside. Well, that's not necessarily true. Okay? If I were to just try to do this as a whole number problem, you're right. I wouldn't be able to get an answer. But remember that now I'm dividing with decimals. So I can, as you'll remember from before, that at the end of every whole number is a hidden decimal. So I put in my decimal and I bring it straight up. And as we just went through on the last problem, after the decimal point, I can annex zeros without changing the value. So now I have what looks like a different problem that I actually can do long division on, even though I didn't change any of the values. Does 5 go into 3? No. So I would put a 0 there. It's too big, doesn't fit. But will 5 go into 30? Yes, it will. How many times? Well, that would be 6. 6 times 5 is 30. So when I subtract, I get a 0. So my answer to 3 divided by 5 is 6/10. If I try to divide a smaller number by a larger number, my answer is going to be a decimal number. It's going to be less than 1. Okay? And I know that that can be a little tricky to understand, but we are able to do that. Okay, so let's take a look at your notes. We'll fill those out, and then we'll come back and do a few more examples. So here are our notes that we're going to fill in. And we are again dividing decimals by whole numbers. So if you'll remember, the first thing we did was to bring the decimal point straight up from the dividend. Okay? And remember always that the decimal point in a whole number is always at the end. Then, number 2, we're going to divide like we normally do, just like it was regular old whole number long division. But we have to be very careful about the placement of the numbers in the quotient. The third step is the one that's a little bit more difficult to remember. It's if you run out of numbers to bring down and the problem isn't complete, we have to annex or add zeros to the end of the dividend, and we keep dividing until the problem ends or a repeating pattern is found. Now, we have not talked about what a repeating pattern is, and you shouldn't have very many problems like that to contend with. But I will show you one that you can write down just so you have an example in your notes. Okay, so let's say that we have this problem, 3 2/10 divided by 6. Okay, this is the third way that we saw the division problem represented. Remember that the 3 2/10 is going to be your dividend, and the 6 is your divisor. So again, here we are dividing a smaller number by a larger number, which is going to give us a decimal answer. Our first step is to bring the decimal point straight up. And now we just divide like we normally do. 6 goes into 3 0 times, which is 0. When I subtract, I get 3, and I bring down the 2. And now I say, okay, how many times will 6 go into 32? Well, that's going to be 5 times. 5 times 6 is 30. When I subtract, I get 2. I'm out of digits, but I have a 2 here, so I have to add a 0, bring it down, and I keep dividing. Well, how many times will 6 go into 20? That's going to be 3 times. 3 times 6 is 18. When I subtract, I get 2. Oh, I'm still not done. Add another 0, bring it down, I get 20 again. How many times will 6 go into 20? 3 times, which is 18. Subtract, I get 2. Okay, do you see that there's a pattern starting to form? No matter what I do, I'm always going to get stuck in this repetitious pattern where I'm not going to be able to end this problem at all. This pattern will go on indefinitely or forever. And there's no need for me to keep dividing once I see that pattern is there. The way that we note that there is a repeating pattern is I write my answer down, 0 and 5, 3, 3. Now what number is going to be the one that keeps repeating? The 3's. So I'm going to put a bar over the 3. Okay? As I said, you're not going to see a lot of these at this level, but I did want an example in your notes just in case.